I'm Chris Rowsell, and this is Stacy Carlson, my co-presenter.
Yes.
So do you want to explain a little bit about AP?
Sure. So AP, if you're not aware, is a large electric utility. We have over 17,000 employees. We have both transmission and generation, and we have 5.44 million customers. And today we're going to talk about our process from going from prototypes to a production line.
Yeah. So this message is going to be like a 10,000-foot message, right, of how basically we went from this guy, a pizza-eating chimp, to several prototypes to a product line, right? So I've been kind of evangelizing, well, we've been doing what, AR, VR now for about 2 years in AP?
2 years.
Yeah, that's cool. And we've been a product line, a Scrum product line for about 8 months, right? But it started way before then. So this message is kind of like a 0 to 1 sort of message. It's more of a kind of -1 to 1. So when I first started to introduce and evangelize AR and VR technology into AEP, first of all, I was going the route of just showing websites and films, and I really wasn't getting much buy-in. So the next step I took was to actually purchase a HoloLens myself. So I purchased a HoloLens, and we started to evangelize, go up the chain, go up the executive chain to prove that this technology could provide value. But I tended to just use the out-of-the-box software, right? And this guy was one of them. I don't know if you've actually seen this guy, but it's think of it as kind of like an animated 3D GIF that you can walk around, right? And I found that I just wasn't getting much buy-in. They could see it was cool tech. They could see that there could be value, but I needed them to get us to meet him halfway. By the way, I just want to say something. You know something I find really interesting about mixed reality and these holograms, and especially this chimp, is when I present it, I often find people will actually walk around it, and they find it pretty rude to walk through the hologram. And I'm like, look, you can walk through the thing, it won't bite, you know? So just don't take the pizza. It doesn't like that. Anyway, so we quickly realized that we needed to come up with a few prototypes. As I said, we got distribution, transmission, and generation, and we realized we needed 3 prototypes to actually talk to them. I say a power of a compelling prototype. For us, compelling doesn't necessarily mean complex, right? It just has to be relatable, and get that user to kind of just get there and understand and ignite their imagination of what this technology can do. So the first prototype we produced, very, very simple, was buyer's run. This was taken from laser scan data that we had taken of one of our substations. We kind of decimated it, did an awful job of decimating it, and because originally it was like 1.2 million polygons, HoloLens wasn't really handling that, so we had to bring it down. So yeah, shoved it on the HoloLens, started to get in front of engineers. And there was this one particular case as they were walking through and they were starting to get excited and relate to this technology that I found really, really interesting. And that's spatial perception. And that's something you get when you use stereoscopic devices. It was one of our training safety guys. He was walking through. He was in a conference room about this size. So that's an advantage to mixed reality technology, is being able to kind of walk through it. And with the HoloLens peripheral vision free, it's a lot more comfortable. That's the way we interact with the world, right? So he was walking through it, and there was one piece of equipment he was about to come up to. It's kind of relevant to what was just said earlier about muscle memory. And he was walking up to a piece of equipment, and he kind of just stumbled and kind of giggled to himself. And I was like, stop. What's going on there? What just happened? And he said to me, even though I can see this is just simple geometry here, right? For some reason, I knew I was about to approach this piece of equipment that I know very well that was in the arcing zone. And somehow his muscle memory kicked in. So that was kind of interesting. So the second the prototype we did was for generation, right? They approached us. Now we're starting to evangelize. We're starting to do a lot of demos. People are getting a little bit excited about it. And so they approached us and asked us, we simply put in one of our CAD models. Did exactly that. I mean, it took a couple of hours, shoved it in on their heads, right? And they got excited about this. Again, going back to depth perception and stereoscopic perception, they were able to kind of quickly view and spot issues within this model that they weren't seeing in the 2.5D, your CAD models on your computer screen, or within the 2D designs. And furthermore, they kind of mused at the idea that maybe as they could walk through and then they could do some changes and then bring in their maintenance guys and basically get them to walk through and play act their maintenance routine, right? So now we're discovering, ergonomic issues. Poor George has got to come in every Tuesday and do a contortion act with a 50-pound, wrench. We can kind of spot those issues. So our third prototype was AP training demo. And this was, again, it's more virtual reality on the HoloLens, right? Just to demonstrate the principles and the concepts. For this one, we noticed, even though this was for distribution, we did notice that the classic use cases, you heard it throughout the conference, training. And so then we went this route. Again, we slammed it together. It took about a weekend to push this thing together. And you're just standing in suburbia. You've got a bunch of issues around you. Maybe there's a generator that's too close to the house. Maybe, the overhanging lines are too low. And you just kind of click on it, and you can kind of answer the question and kind of measures, whether you got the answers right. But we took it one step further for our demos. We wanted to demonstrate AR principles in a VR world, because it's a lot easier, with Unity or programs like that to create that, very concept. And you see, got to get my left and right. On the left-hand side there, if you clicked on the pole, you get the asset information and real-time information back that we kind of simulated. And I know that a few of you guys are actually doing this in reality. If you see on the left-hand side there, you click on an underground view, you can see the underground assets. And that allowed us then to demonstrate those principles to, to potential BUs who were interested in this technology. So from there, Stacy's going to say what happened.
Sure. So all of these prototypes, fortunately for us, were compelling enough, right, that we did actually get the buy-in we needed, and we were able to get funding for a proof of concept project. And part of that proof of concept project was joining a study that EPRI, or the Electric Power Research Institute, was looking into augmented and virtual reality in the utility industry. So with that, we needed a use case, and we actually partnered with our transmission group to look at something that they were already looking at. There was some synergy in what they were doing with virtual site visits. Now, their virtual site visit initiative was looking at conferencing software and smartphones, smart tablets, right, to limit the number of people that they sent into the field to do their actual site visits. But they wanted to get a hands-free version of that for safety reasons. So they were able to partner up with us. It was a partnership between IT and the business unit, right? And the three main goals we had as part of that proof of concept was in first trying to enhance that 3D station scoping or virtual site visit initiative that they already had. But we didn't just stop at the remote buddy system, right? We also added some additional requirements onto that where they wanted to be able to do some visualization of their models, both in the office as well as in the field, which is a pretty big use case. Wow. I don't think we realized how big at the time.
Eating a virtual elephant.
Yeah. We also looked at safety and security. From a safety perspective, we wanted to make sure that the devices and technology that we would be putting on our employees wouldn't be detriment to them, especially when we were looking at energized substations. We also needed to look from a security perspective. Security is very important in the utility industry. That the devices could be secured on our network, and also that our infrastructure could support it. And if it couldn't, what steps would we need to take to get us there? We looked at 3 devices. We already had the Microsoft HoloLens, so that was one of the devices we looked at. We also looked at the DAQRI Smart Helmet and the RealWear HMT1. So really, really quickly, we learned what all of you probably already know, that there wasn't one device that would meet all of our requirements for any use case, and that our use case happened to be probably 2 or 3 use cases rolled into one. Safety was the big issue for DAQRI and HoloLens at the time, right? We weren't able to wear PPE with that. The hard hat didn't work for the HoloLens at the time. They didn't have the attachments that they do today. And the DAQRI, even though it was a helmet, wasn't certified for use as a hard hat in the field. So did not meet all of our requirements. The RealWear met our PPE requirements, but it didn't actually meet the 3D stereoscopical visualization that our business unit wanted. So at that point, we needed to pivot, right? We had to make some decisions. Which requirements were most important to us at this time, and which did we want to move forward with? And right about that same time, one of our designers had approached us with a new standard model that he had wanted us to put into the HoloLens. It was actually a new standard that they were working on for a distribution switching bay, and it was prefabricated. So the model was a lot more compact than it had originally been or traditionally been, because it needed to fit on the back of a truck. The engineers and designers came up with a model they thought would work, but when they showed it to the field service engineers, they felt very differently about it. They did not feel that the model would work. They didn't feel they'd be able to perform the switching and the maintenance that they would need to do on that model. And they had been going back and forth for several months trying to come up with a solution. So we put it in the HoloLens, and we actually have a video that we're going to play that will show the results of that. Okay.
So, I'm entering the substation now. I can now look at it. I can look for the abnormalities I would normally look for, like, say, the missing ground on this stanchion over here. But what's more important is I can actually now look at the orientation of these switches and just how close I have to actually stand to them in order to operate. You've done a great job of adding these pads, so now I can actually see where my feet are in relation to where I'm standing. Okay, going back to the idea that safety is involved with this, I can actually enter into a world with safety hazards in it without actually putting myself or anybody else in danger. It also allows me to watch what a person is doing and correct problems before they actually go out into the field and recreate those problems. I can correct these actions ahead of time.
We had done an initial run, and he got in there and he critiqued it. I mean, there were some things missing that you wouldn't even see if you were looking at it on 2D sheets. So with him inside there looking at it, he was able to pick up some things that we needed to add to it so he could look at it again. So that was eye-opening for us.
Yeah, so the first things first on that one, you don't really see it in the video, but and I'll explain in a second, but we actually managed to provide value during a proof of concept. I'll explain. So the first thing is, there's three things I like about that is during their collaboration session, like I said, you don't see it, it took about 20 minutes for them to come up with a solution. So I don't know if you know what a switching bay is. As you saw there, it's a giant structure that you use to switch off different parts of the substation so they can be worked on. So the second bit I really like about the idea of that was they were taking a real-world object, a hot stick, and using it in a virtual or augmented reality world. And that's pretty powerful. And everyone could kind of see the problem at that point. And if you see there, we kind of give them a few different configurations options, and that's how they managed to solve it. Like, okay, this is much better. I got a good escape route, so that was fantastic. The other thing I like about 3D stereoscopic, mixed reality collaboration, humans are very visual creatures. Even when we're talking, we often point at things, and having mixed reality, virtual reality, mixed reality objects in the same space in reality and being able to kind of interact and go, yeah, that's stuff there, and that stuff there, that was lucky. So that was really, really powerful for us. When we got kind of validation with that, observational validation. So a couple of weeks later, you see there on the left-hand side, got one of our directors and our managers who we did the model for, we actually showed the demo of that model for. And this is perfectly caught moment, right? They're both there and he's pointing and he's going, what is that? Why is that there? And it turns out he's pointing in, I think it was an animal mitigation box?
I think so.
He's like, that's too low. And you're just missing a moment because the manager's about to kick in and go, whoa, whoa, whoa. No, we discussed this 2 weeks ago, right? We were looking at 2.5D drawings. We were looking at, the 2D drawings. And yeah, we were on par. And that was the thing for me. They had walked out of that meeting thinking that they were on the same page. And it wasn't until they saw it stereoscopically and with, spatial perception, be able to walk around, that they realized it was a little bit too low. So that was a good moment for us. We provided value. So.
Absolutely. Okay, next we'll talk a little bit about enterprising the solution. Can't emphasize enough how important it is to get your safety group, your security group, as well as device management involved as early as possible, make them part of your team. To be able to really push something like this into production, they all need to be involved in the table very early on. We realized quickly that our team was not just our core development team, but many, many parts of the organization, and they were hugely important because there are a lot of processes, a lot of standards that need to be looked at, and just hugely important. Just a few screenshots of some of the testing we did. We have something called Dolan Labs that they were able to do some testing on the HoloLens, as well as the industrial hygienist doing some tests on the daiquiri. So it was a lot of fun, actually. Future use cases. So we did a lot of demonstrations. We held a lot of innovation blitzes and events to really evangelize and communicate to people what the devices were capable of, and really all of our use cases came from our end users, right? And that's really, I think, we feel very strongly that that's where your best use cases are going to come from. They're the ones that are going to be able to help you make those business cases and make sure that whatever you're developing is actually used in the organization and is providing value. So highly recommend that. Also, idea capture capabilities. You need to make sure that you have something in place to capture all those ideas because they start coming in from everywhere. And you want to make sure you don't lose those. So really important. We ended up coming up with over 100.
I think it was 100 use cases.
100 use cases. Now we were able to consolidate those down into different buckets or areas because there were a lot of similar ideas, but they were different parts of the organization, right, that are looking for similar things, which also help you build your use case. So out of those 100 use cases, we ended up coming up with several capital projects. The first was, these are just our demos. Forgot about that, sorry. And our application, so GenAR was our first application. It's a native iOS iPad application. It pulls real-time PI data or operational data for our plant equipment into overlays over that equipment in the field using marker-based technology. It's really helpful to the operators in the field to be able to get some real-time data on the equipment, which in the past they were only able to access through the control rooms, right? So this was a small deployment, just to put that out there, that concept of failing fast or learning fast, right? We took a very small take on this. It's one plant that it's been rolled out to, only 6 pieces of equipment. It's really just to prove that we could do it and how that would work. So future projects will expand that, the configuration, adding more equipment, more plants. But we were able to prove that this was something we could do in a pretty quick time frame, which builds that trust with the organization that we can actually do some of these things today.
So second production app, small amount of users, so we're claiming victory on this one. It is kind of production. Talking about the power of a compelling prototype, this one actually stemmed from a very, very quick prototype that we slammed together. Again, a couple of hours. We just got the assets, shoved it in, gave it to our sponsor. And our sponsor then really quickly saw the value and then came up with this idea. Bold, which basically has an innovative new sort of tower. It's a very good looking sort of tower, not the scaffolding structure. They often go out and try and sell the tower. And so just think about this, it was on HoloLens, just think of it as like a 3D PowerPoint presentation. But it did really attract a lot of people, and kind of provided a visual value where they kind of struggle with like 2D literature. So that actually then stemmed on from this little project. As we continue to explore, we also started to look at the device in your pocket. Again, using marker-based technology. All we did, we got a simple business card, shoved the model on top of it, and what this actually helps is a lot of the salespeople that are out there quite often don't have the literature on them, and they bump into these opportunities, and they're trying to explain, the features of this new tower. So they just simply bring out the card, point the phone, and boom, there is this just easy to explain visually the benefits of this particular tower. I think it's coming out on the store soon, actually.
It is, probably within the next week or two. It should be out on the Google and.
I reckon we'll get 10 million downloads on that thing.
So, and last but not least is our station standards project, which is kind of a carryover from our proof of concept, creating a viewer for the transmission station organization to be able to view their models stereoscopically in the HoloLens. With that, we're creating a repository for them to store their models that will be business unit managed. So that makes them independent from IT, and they can manage what models they want to view in the HoloLens, and there will be a collaboration aspect of that as well.
Yep.
I think we have a quick video.
Quick video,
Yeah,
you've got
that you're
12
gonna
seconds. So, fortunately I was going to do a live demo, but the demo gods weren't with us. There's a thing about, casting is sometimes you have bandwidth problems. That's what we did. So we got this video here. What you're seeing is a very simple repository that we created on the back end. The purpose of this is, if you noticed, it often led to the fact that our business units were coming to us to put the models in an app and then pass it back. So we're trying to kind of make our business units independent of us in that sort of step. So like I said, we've got a centralized repository. They can do the bits to the models, put it in there. We've got this viewer that allows them to kind of manipulate, add their models from that little catalog. They can put, it's free to whatever they want to put in there. If you see here, just putting it in. I'm sorry if this is making you sick, by the way, because my head moves like crazy. That's one thing about what you see, what I see is what you see. Technology is, sometimes people feel nauseous. Yeah, again, you can just manipulate it, and I think you can just put it in, I think it'll go to full view in a second. So you got a little tabletop scaled view, you can walk around it. As Stacy was saying, we're going to make this collaborative, so have these rooms where you can people can kind of collaborate, look at their models, spot the issues. And yeah, just trust me, you can go to full scale with this thing. Let's have a look.
Change scale.
There it is, right on time. So really, that's really all that is at the present moment, but we are expanding it. So I just want to say thank you. This is our first time at EWTS. It's been bloody fantastic, I've got to be honest with you. So thank you very much.
Thank you.
Thank you, well done.